Oh, okay, now you can. All right. Well, first of all, I'm sorry this has to be in English because I don't know French. I should learn because I come to France often enough that I should probably learn some French. But anyway, my name is Mete Atamel. I'm a developer advocate at Google. I'm based in London. And today I want to talk to you about WebAssembly, especially when it comes to running it outside the browser. Now, my slides are already on speaker deck, so if you want to get the slides, they're there. And I'm going to show some demos as we go along, and those are already on GitHub. So everything I show today, they're available to you, and I'm going to share the links at the end of the presentation too. So if you want to take pictures now or later, it's up to you. And before I start my talk, I need to earn my trip here. I need to talk to you about the Innovators program that we have at Google Cloud. So if you're using Google Cloud, or if you want to use Google Cloud, there's this program that you can join, and you get free learning and free credits and things like that. So feel free if you want to join. All right. Now let's get into what is WebAssembly and why we should care about it. What is WebAssembly? If you look at webassembly.org's definition, it says WebAssembly, also known as WASM, is a binary instruction format for a stack-based virtual machine. So it's a virtual machine, but also it's designed as a portable compilation target for programming languages. So you write in your own programming language, you compile to a WASM module, and you run in a virtual machine. You know, at this point, if you're a Java person, you're probably thinking, OK, this sounds similar to Java, isn't it? And it is similar in that sense. But WebAssembly tries to do this in a more generic kind of way. So it's not for Java ecosystem, but it tries to target every language, basically. At least that's the aim. And what was the point of WebAssembly? The original use case for WebAssembly was to augment JavaScript. I don't know you. I don't like JavaScript. But for better or worse, we are stuck in the browser with JavaScript. But sometimes you can't do things in JavaScript, right? So if you have games or 3D graphics or anything that's kind of heavy, you probably have that written in native code. And the use case for WebAssembly was to take that native code, compile to a WebAssembly module, and run within the browser. And all the major browsers, they support WebAssembly. So there's been great support for WebAssembly within the browsers for a while. And this is exactly why I ignored WebAssembly for the longest time, because I am a backend Java cloud developer. And for me, WebAssembly looked like it's something not relevant. You know, it's a front-end technology, and it's not even normal front-end. It's for this heavyweight 3D graphics games kind of front-end, right? So it wasn't my domain. So I kind of ignored it for a long time until I started seeing some tweets. First, there was a tweet back in 2019 from Lynn Clark, she started talking about running WebAssembly outside the browser using a project called WASI. When I saw that, I was like, OK, you know, everyone wants to run everything everywhere. So what's the big deal? You know, yeah, you can run WebAssembly outside the browser. But I didn't really pay that much attention. But then I saw a reply to that tweet from Solomon Hykes, who's the founder of Docker. And he was talking about WASM and WASI. And he said that basically, if WASM and WASI existed back in 2008, then maybe we didn't have to create Docker. So that's when I started paying attention, because Docker and containers have been the de facto standard in the last 5-6 years of packaging our code and running it in places like the cloud. Now, if WebAssembly, and especially with WASM and WASI, is the thing that's comparable to that, so maybe it's something that I should also pay attention to as a backend developer. So that's when I started looking into WebAssembly, what it means for me as a backend developer, and that's how this presentation came along, basically, out of my research in that field. And there was a survey from CNCF last year, and one of the key findings of that survey was containers are the new normal, and WebAssembly is the future. Again, this reinforces the idea that, you know, we've been using containers for a while, but maybe WebAssembly will be the next thing after the containers. So what does it mean running WebAssembly outside the browser? Well, there's a project called WASI that we'll talk about. And WASI tries to basically free WebAssembly from the browser and let it run in other places. And the idea here is that, you know, instead of running applications as virtual machines or containers, you can run them faster, smaller, more secure, more portable way using WebAssembly modules. And this sounds great, right? I mean, who doesn't want to run things faster, smaller, more secure, more portable way? But what do they actually mean? So by faster, WebAssembly modules, they start with minimal cold start. Actually, there's no cold start. So they start really fast. There's basically no cold start. So compare this to containers or even serverless functions, it's nice, right? I mean, in containers, there's always this overhead of starting the container. Even with serverless functions, there's about 200 milliseconds of latency where things start up. Whereas with WebAssembly, at least the aim is that it starts instantly, so you don't have to pay for this cold start. The smaller part, the WebAssembly modules themselves, they're really small. But even when you take the WebAssembly module and put it in a container, and I'm going to talk about why you want to do that later, but even that ends up being smaller. And there's this great blog post from Nicholas where he compares a native Docker container to a WebAssembly Docker container, and it tends to be 3 to 20 times smaller, and we'll go through that later. By the way, Nicholas is also at this conference, so it's nice when you go talk about someone and they show up at the conference that you're speaking. But we'll go through that blog post and look at the details of what that means. But they tend to be smaller, WebAssembly modules and WebAssembly containers. More secure. In containers, everything is allowed, almost everything is allowed by default. And you need to kind of harden it a little bit to make sure that your container is secure. And this makes me really nervous because every time I'm writing code, I'm thinking about code, then when it's the time to actually build the container, I copy and paste from somewhere usually because I'm not an expert in building containers in a secure way. But I always think, is this the most secure way of doing it? Because it always makes me nervous. What did I include here? Is it the minimal thing I can include? Sometimes I remove things, but then I realize that my container doesn't work anymore because I removed too much. Then I add things, and it makes me nervous because I added too much. Well, WebAssembly kind of gets rid of this problem, because in WebAssembly modules, everything is denied by default. So basically, nothing is allowed, which means I can sleep. But if you need to allow something, you need to explicitly allow that. So you need to explicitly export functions. You need to explicitly allow file system access. So you need to actually think about it and allow them by default. So allow them one by one. So it's not allowed by default, basically. So this tends to be more secure. And sometimes we forget that if you compile code to, let's say, Linux AMD64, it's not going to work on Linux ARM64, even though they're both Linux, right? And forget about running it on Windows. Whereas in WASM, once you compile to a WASM module, you can take that and run it anywhere you have the WebAssembly runtime. So that's a really great story for portability. So these all sound great, but let's look into more details. Well, before we get there, so now, basically, the way it looks to me right now is that we came a long way from the times where we had the code running on the hardware, then we had the VMs on the hardware. At some point, containers came along, and we started running containers on VMs. And now I think we're at the stage where we just run containers, and we use technologies like Cloud Run, for example, on Google Cloud. It's a service, you just run containers, but you don't even know what's underneath, and you don't even care because it just runs your containers. So we are at that stage, and maybe WebAssembly will be the next stage from there, where you take your code, compile into WebAssembly module, and you just run it more efficiently without having to care about what's underneath again. So is this the future? It feels like that, but we are not there yet. We are hopefully getting there. And then before we get into details, you might be wondering at this point, OK, this sounds great, but what kind of use cases I should be thinking about when I'm thinking about WebAssembly? And I think there's 4 main use cases. And there's a blog post from Fermion, which is a startup focused on WebAssembly. So you can read in more detail in the blog post if you like. But basically, what they're saying, and what I also agree, is that there's 4 main domains. The first one is the browser domain. That's been around for a while. So you have some native code. You want to run it within the browser. You can just use WebAssembly for that. And that's established use case for WebAssembly. The second case that's coming up is what's called the plugins and edge use cases. So the idea here is that you have something running in the edge, and you want some custom code to be plugged in into the edge, right? For example, Shopify has something called Shopify Functions. It's a way to customize your your checkout experience in Shopify. And what they allow you to do is that they allow customers to provide their own code within that checkout experience. And for that, WebAssembly makes perfect sense because first of all, you can let customers use whatever language they want. And secondly, the code is protected within the sandbox. So if there's some problem with that code, you can kind of disable it, or you can be sure that it's within the sandbox, basically. It's not going to bring down your whole kind of checkout experience. Also, Envoy has something called Envoy Proxy, and then they use filters to filter traffic, and they allow people to write their own filters in WebAssembly and plug in their own code. Again, it's a good use case because people can write their own code, but it's sandboxed. So that's one area that's coming up, and there's some traction there. Another area is IoT, because WebAssembly modules tend to be small, so they kind of make sense to run on IoT devices. And the last area is cloud microservices, and that's the area that I'm interested in as well. And this area is basically about take your existing code, but run it more efficiently using WebAssembly. And there's a startup, Fermion, that has a framework called Spin that tries to make this easier, so that you can use their framework to write a microservice that you can compile and run on WebAssembly. So these are the 4 main use cases. So if you're in any of these fields, then you might want to start thinking about WebAssembly. I don't think you would want to run, or you can run production-level code yet in WebAssembly, and I'll explain why later. But at least these are the domains that you should be thinking about when it comes to WebAssembly. All right, now let's start getting into details. So WASM runtimes and WASI project. So as I mentioned already, normally you take your source code, compile to the architecture that you want. But in WebAssembly world, you just compile to a WASM module. So you don't have to think about the architecture. It's just a single module for all architectures. Now, then you take this WASM module, and you run it on wherever you want. All you need is a WASM runtime installed on those architectures, and the same module, a module compiled on one architecture, can run on another architecture because of the runtime that you have. Now, these runtimes, there's a lot of them, but there's 3 popular ones that I've seen. One is called WASM Time from Bytecode Alliance project. This project is the one behind the WASI project that we'll talk about. Another one is called WASM Edge. This is from CNCF. And another one is called WASMer from a startup. But actually, if you go to this GitHub link, you will see that there's a ton of runtimes. And they kind of focus on different things. Like, so if you want to run, for example, WebAssembly on IoT, there's a runtime for that. So what I would suggest is that, to use WebAssembly, to play with it, these 2 or 3 are the good ones. But if you really want to get specialized, just check out this link and see what runtime might make sense for what you want to do. All right, so once we have our module running in the runtime, now we want that module to access the host. And that's when WASI comes into play. WASI is WebAssembly System Interface. And it tries to standardize how WebAssembly modules talk to the host. For example, if you want to talk to the file system, the way you talk to the file system is different on Linux and Windows. So WASI tries to give you that common interface so that you don't have to worry about the underlying different operating system. And WASI, it's POSIX inspired, so it tries to implement parts of the POSIX, but very small subset. And it's in preview 1 right now, and preview 2 is coming later this year, which means it's not done yet. It's changing constantly. And it tries to give you the minimal set of functionalities. For example, it gives your WebAssembly module the ability to read and write files in a sandbox environment, program arguments, environment variables, so on and so forth. But a lot of WASI is in proposals now. They are not implemented yet, and there's a lot of discussion around it. And it's kind of slow-moving project because it started back in 2019, and now we're in 2023, so it's been 4 years already. And there's no socket support, for example. There's a socket proposal, but it's not fully finished or implemented in runtimes. So without socket support, you can't really run services, right? Because if you can't read and write from sockets, then you can't do HTTP and things like that. So it's very limiting. And because of that limitations, some runtimes, they try to go around them, and they try to implement their own sockets. For example, WASM Edge, one of the runtimes, they have extensions for sockets, but they are only supported on Rust, JavaScript, and C. So yeah, if you are on WASM Edge and if you are on Rust, maybe it will work, and maybe you will have some socket support, but for everything else, there isn't. Then there are some projects that try to enhance WASI. One of them is called WAGI. By the way, in WebAssembly, everything is like WASI, WAGI, WASIX, so it's all like that. But WAGI, what it tries to do is it tries to add HTTP handlers around your WebAssembly modules. So your module doesn't understand HTTP, but WAGI tries to kind of bring HTTP to your modules, and I'll show you an example of that later. There's a whole new project called WASIX that tries to add full POSIX support on top of WASI, but it's a little bit controversial, and I'll explain why later. And there's no garbage collection yet in WebAssembly, but there's a proposal. And actually, I just learned a couple days ago that Chrome now supports WebAssembly garbage collection, so I need to look into that. But basically, if you are from a garbage collected language, then it becomes complicated because WebAssembly doesn't have a garbage collector, so you need to ship your own garbage collector with your module, and that makes your module more bigger than it needs to be. So it's kind of a mess there as well. So as you see, like WASI is kind of like the first step in trying to support WebAssembly outside the browser, but it's not there yet. It's proposals or missing functionalities. All right, now I talked a lot, so let me just show you quickly how you can take some code and compile it to a WASI module and run it on a WASM runtime. Now, the way you do this depends on the language quite a bit, and every language, they have different levels of support for this. And in my repo on GitHub, I try to kind of go through different languages and play with them. So I did that for Rust, .NET, Go, and Kotlin. And I will keep adding more. But it's a very fast-changing space. So I'll just show you an example with Rust, because Rust is one of the best supported languages for WebAssembly. But it will be different depending on what language you want to use. So let's take a look at that. So first, what you need to do is you need to have your Rust installed, and you need to have a WASM runtime installed. So in this case, I have WASM time installed on my machine, or you can also use WASM Edge. So it doesn't really matter which runtime you use for these applications. Then in Rust, you need to add this special target, WASM32 WASI. This adds WASI support, basically, to Rust toolchain. So I already have this, but let's make sure. So this will, it tells me that I already have that. But if you don't have it, it will install the toolchain for WebAssembly. And then you create your application. And just to show you the application, it's a very simple Hello World one. But one important part is that, in this Hello World, we just say Hello WASM, but we also access the file system here, right? So I'm creating a file in /Hello World directory, and then hello world.txt file. So I create that file. I also write hello world to that file, and then I do another println afterwards. So it's a very simple app, but the main point is that it's accessing the host. So it's trying to write a file to the host, which is my laptop right now. So we have that. And then to compile this for WebAssembly, I should say WASM and WASI, you basically need to add this target, and this will basically compile your app to WebAssembly and WASI. So let's actually copy this. And first of all, let me see if I have, I have that. So let's clean this. OK, so I don't have the WASM module now. Now I do the build, and then it will look at my source code, and it will compile. And then now, if we do the WebAssembly module is there. And then once you have the module, you can run it in a runtime. But remember, the module is running in a sandbox, so it doesn't have access to the file system. And I told you that in WebAssembly, everything is, by default, not allowed. So you need to kind of give explicit rights to access the file system. And that really, it really depends on the runtime. So in WASM time, for example, you will use this flag, map directory. And what you're saying here is that the /hello world in my WASM module maps to the current directory on my host. So by doing that, you're giving your module rights to access your file system. And then you just point to your WASM module. So let's actually run that. And then, yeah, so it said hello WASM, and then it also created this hello world, and then it can access to my host, which is good. Now you can take the same module and run it with WASM Edge, another runtime, or you can even run it on Windows if you like. But in WASM Edge, the map directory is different. It's just there. So you would use that, and then if you run it again, it will work with WASM Edge as well. So you see, the runtimes are, you can choose whatever you want, and you can even run it on different kind of environments as well. All right, so that's that. That was just a quick way of showing you how this works. Let's move this here. OK. Now, at this point, you have your WebAssembly running, and you might want to look into how you can run that in Docker, because Docker is kind of the de facto standard of running things, right, in the cloud. But at the same time, you might be asking this question, why run WASM inside a container anyway? Because I kept telling you that how it's great, how it's smaller, better than a container, and now I'm telling you to run within a container, right? Well, the idea here is to combine what we have today with what we're going to have with WebAssembly, right? So today, we have containers, and we have an ecosystem around containers. We have container repositories where you can push and pull images. But for WebAssembly, we don't have that ecosystem. So how would you run your WebAssembly module? Where are you going to store your WebAssembly modules? Where are you going to pull them and push them, right? So I think this kind of makes sense for today, so that we can use our existing ecosystem, but start getting the benefits of WebAssembly. But in a future world, I can see kind of WebAssembly existing on its own, and we have the toolchain around just WebAssembly, and not containers, OK? So that's why I think people do it. And another reason is because you still get much smaller containers. And let me go to this blog post from Nicholas, where he looks at this. So what Nicholas did, and he did a great job of explaining this stuff, is that he basically said, OK, let's take a Hello World application and build a WebAssembly module out of that, and then and put that in a container, right? And to put it in a container, all you basically need to do is this called scratch image. Scratch image means it's an empty container, basically. So you are based on that image, and you copy your WebAssembly module to that image, and then you just run it. Because WebAssembly is self-contained. You don't need to do anything. You don't need anything on top of WebAssembly. So you do that, and then you build your container just like any other container. And then when you run it, Docker has some runtimes, WebAssembly runtimes already installed. So you pass in this runtime flag, and in this case, we are running it on WASM Edge. And you point to your container image, and it just runs, right? Now, he did the same thing, but this time without using WebAssembly. So he took the same application and built a self-contained Rust application out of that. And I guess this is how you do it in Rust, by passing this flag. It's also based on the scratch image. So in Rust, when you create a self-contained executable, it has everything it needs. But then when you compare the sizes of the two, you see that the native one is 7 megabytes, and the WASM WebAssembly one is 2.6, so it's like 3 times smaller. Of course, this is a little bit of cheating, because the WebAssembly runtime is not in the container. It's provided by Docker, right? So that runtime is outside. So because of that, this is smaller, right? But I think this is still a win, because you don't need to think about what I need in my containers. Once you have your WebAssembly module, you don't need anything else. And then he went on, and he tried to create more complicated samples where he was trying to do HTTP calls and things like that. So I won't bore you with the details. You can read them later if you like. But the important point is that at the end of it, when he did the comparison, so 1.2 is the latest image, it was 123 megabytes, but the WASM one was 5 megabytes, right? So it's much smaller. And again, this comes down to you need much less in your Docker image as a base image, because in WebAssembly, you don't need anything, basically. Whereas in native, you need to figure out what you need and make sure that you put those in your container, and it ends up bloating your container images. So this alone, I think, is also a good reason why it kind of makes sense to run WASM inside a container, even if it doesn't technically make sense, because WebAssembly by itself is even better, Okay, and how is this possible? So how can we run WebAssembly modules within Docker? It's possible through this project called runwazi. It's a project to facilitate running WebAssembly managed by containerd. And starting in 4.15, Docker uses runwazi to run WASM with WASM Edge, WASM time, spin, and slide runtimes. So Docker basically supports these 4 runtimes, and it uses a runwazi under the covers to do that. Azure, they have Kubernetes service, and they're also previewing a WASM node pose that also uses runwazi. So you should be able to run, again, these modules on AKS using runwazi under the covers. And just to look at this quickly, there's this great blog post from Nigel that explains, today we have Kubernetes and we have containerd managing runcs that run the containers, right? That's how today's world works. So containerd managing the containers, basically. But in this new kind of world, you still have containerd managing things. But some of them, they can be WebAssembly modules. And this is possible through this special shim for WebAssembly. And this shim has the runwazi project, and it also has the WASM runtime in it. And with that, you can run WebAssembly modules. So you can read more about this, but basically, it's kind of the old world and the new world kind of coming together with these projects, and runwazi is the project that's enabling that. All right, now let's look at taking this same app that we built, but putting in a Docker container. So let's go to so the run WASM Docker. I can close this. So what we need to do here is basically, I built the same app, but I changed it so that it just says hello world, waits 10 seconds, and then it says hello world afterwards. You build your WebAssembly module just like before. In Docker, you need to go to your settings, and you need to enable some experimental WASM things. So if you look at under features in development, you need to make sure that containerd is enabled. And you also need to enable WASM here. This enables the WASM runtimes on Docker. And you also need to make sure that you're on the latest version of Docker, because the earlier versions, they don't seem to work that well. So once you have that, you create your Docker image. And as I mentioned already, it's based on nothing. So it's only on empty kind of base image. And you copy your WebAssembly module there. And then you build your image just like a regular image. And actually, let's do that. Let me see if we are in the right place. So yeah, you build that. I already have it built, so it's going to be there. And then to run it, you just pass in this runtime flag, and you pass in either WASM Edge or WASM time or spin or slide, like whatever runtime you want. So if we do this, now this is running within the container, and if I do Docker PS, I can see that there's a container up and running. But yeah, it's WebAssembly in the end. And the beauty of this is that you can then push this image to the Docker Hub, and you can pull it. So yeah, we are kind of integrating this into our usual container kind of world, OK? So that's how that works, which is pretty straightforward, because you just don't really need a base image. So let's move this again. All right. So this is all good, but now we want to work on actual services, right? Like we want to be able to run cloud microservices, for example, using WebAssembly. And that's not possible today because of the WASI limitations. But there's a couple of projects that's trying to solve that. One of them is called Wagi. And it stands for WebAssembly Gateway Interface. So if anyone remembers CGIs from back in the days, it's similar concept applied to WebAssembly. And the idea here is that your modules, they don't understand HTTP, but WAGI kind of sits in the middle. There's a modules.tml file that maps the paths to your modules. And when a path HTTP request comes in, it figures out which module should get that. And the module receives that as standard input, OK? And then the module replies back with standard output. So your module is basically reading and writing from standard in and out. But WAGI kind of translates that to HTTP and sends a response back, right? So it's a little bit of hacky if you think about it, because instead of writing proper applications with proper HTTP support, we are kind of using standard in and out to do HTTP. But it kind of works. And just to show you this modules file, so here, I can close this. Yeah. So I have this example that I won't go into too much detail, but basically I show you how to install WAGI and then create a .NET application and build a WebAssembly module out of it. By the way, .NET has pretty good support with this WASI SDK, so you just add that package and you can write your application. But the interesting thing about the application that I want to show you is that it's just a console application. And when it receives a request, it replies back by writing to the console, right? So here we are writing back content type, text plain, and then we are writing back HTTP status 200, right? And then we leave an empty line, and anything after that is the body. So here we are writing the body. The headers, HTTP headers, they are sent, they are placed as environment variables, and the query parameters of HTTP, they are sent as command line options. At least that's the idea. In C#, in .NET, it doesn't work. I tested it, but at some point I'll fix it and it will work. So you see it's a console application that's reading and writing from standard input. And then I do the same thing with Go. In Go, there's a project called TinyGo that adds the WebAssembly support. So I create this Go application, and as you see again, it's a console application. It does the same thing, just writes to the console for HTTP, and then it reads the headers via environment variables, and it reads the query parameters as command line options, right? So once you have that, these two modules, then you create this modules file, and then you say, OK, this path /C# goes to this module, /go goes to this module, right? And let's actually run this. So I just do WAGI and point to the modules. And then if I do curl, let's see. Yeah, so curl C#, for example, then you see that it's the C#1 responding. And then if I do another curl for, Go, then yeah, you see that the Go one, this is the Go one that's responding. So it's one way of kind of having HTTP around your WebAssembly modules. It's not ideal, but at least it's a way. Another way that's coming up is called WASIX. And WASIX, it tries to add POSIX, full POSIX support on top of WASI. So it tries to add networking, multi-threading, and all the missing things, basically, all the things that we want, but it's not in WASI yet. And I feel like it's coming from a point of frustration, because WASI has been sitting around for a while, and they still don't have support for things like sockets. And people working on WASIX, I think they're from a runtime called Wasmer. So they're the same people. They created WASIX as a way to push the project forward. But the problem is that it's only working on their own runtime, and it's only working on a special version of Linux and Rust. So it's very limited today. So it's not like something you can take and run everywhere. But it will be interesting to see how this evolves and whether it pushes WASI to where it needs to be, basically. All right. I showed you this demo already, the WAGI one, so we'll skip this one. And one thing I want to mention, there's a lot of frameworks around WebAssembly. But if you are into running services, microservices with WebAssembly, there's a framework called Spin. It's an open source framework by a company called Fermyon. And it's a good place to start, basically, with microservices and WebAssembly. What they do is that they give you this framework where all the HTTP handling is done, and they use Wagi under the covers, just like the one I show you. They have SDKs in different languages, and all the WASI-compatible languages are supported. So it's a good place to start, and I actually have a demo. I won't show you now because I only have 5 minutes left. But just to give you the flavor of what that looks like, let's close these. Yeah, so for example, if you want to run Python with Spin, it's as simple as installing the Python extensions. Then Spin has templates, so you can say spin new HTTP Py, which means it's an HTTP-enabled Python application. And then you just say spin build and spin up. That's it, right? And that gives you a Python application running within WebAssembly, using Wagi under the covers for the HTTP handling. But you don't need to worry about it. You don't need to worry about the runtimes. You don't need to worry about Wagi, nothing. Like, you just spin up, spin down, spin build, and that's it. So I think it's a great framework. Just check it out if you want to start with WebAssembly services. So I won't show that. And last thing I want to mention is the language support in WebAssembly and WASI. Because one question I get is that, I'm using this language. Is it supported on WebAssembly and WASI? And that's a complicated question to answer. And the reason is, first of all, there's a lot of misinformation out there. And I'll give you 2 examples. Like, this is from Fermyon's website, where they list languages, and they tell you what's supported on that language. So let's say you're looking at Java, for example, right? So Java is supported in the browser, and it has WASI support. It makes you think that, OK, Java is a fully supported language. Then you look at Rust. Everything is supported on Rust, so it must be perfect. I can take any Rust application and run it on WebAssembly. That's what you think. And then you go to another link, and this is another runtime or framework. And then they say, excellent support for Rust, excellent for C++. So it makes you feel like, OK, I can do everything I want. Well, the reality is not that simple, actually. Because, first of all, you need to remember the WASI limitations. WASI limitations apply to all languages. What that means is that if you are on Rust, you can't use Tokyo or async because they need multi-threading, and there's no multi-threading support, right? So if you are writing Rust services, you usually use these things, so it's not going to work. In C and C++, excellent support, but you can't have C++ exceptions or threads. Well, without exceptions and threads, you're going to have a hard time scaling a system, I guess. With Go, there's support, but you need to use something called TinyGo, which is a separate project. But TinyGo doesn't support reflection, so if you rely on reflection, too bad. C#, they actually had good support in .NET 7 with WASI SDK, but they totally changed that in .NET 8 preview, which just G8 the other day, I think. And then there's this WASI experimental workload that you need to install to use it. So it keeps changing quite a bit. Java is supported excellently, except you need to rely on something called TVM, which is Java to JavaScript compiler. And you need to use a fork of that from Fermyon. So if you use the fork of TVM, maybe you can take some Java code and compile to WASI and run it. So the conclusion is that this space is very complicated and very messy today. And it keeps changing from version to version. So it's not like you can take the language and compile and it works in WebAssembly. You really need to figure it out on your own, what works and what doesn't work today, which is not great. All right, so let me finish with some conclusions. WASM outside the browser, as you see, it's a fast-changing landscape. And I need to basically every month or so go and check my references and make sure what I'm saying is true. Sometimes it ends up being not true because things change so fast. The standards and language support, they need to mature. Yeah, WASI needs to be get out of preview, and it needs to support the basic things that we're looking for. The language support that I show you, they need to mature so that all the languages, they have this base level of support, and it should be clear to people what you can do with that language on WebAssembly. Right now, it's not clear at all. Will it replace containers? I think as a technology, WebAssembly has the potential to do that, because if it really delivers on smaller, faster, more secure premise, then yes, why wouldn't I use WebAssembly if it can do all those things? But today, I don't think it's there yet. So it's a space that we should really watch out and see how it evolves in the next couple of years or so. But yeah, it's a good time to learn, and that's what I try to do, and that's what I try to tell you. So thanks for listening, and yeah, let me know if you are using WebAssembly in any way, especially on the server side. I'll be really happy to hear from you and see how you use it or how it works or doesn't work for you. So thanks very much. I don't know if we have time for questions. Do we have time? Can we or no? Okay, maybe we take one question if there's anything. Any questions? Yes.
Can we expect WebAssembly runtime in Google Cloud?
That's a good question. It's something we were thinking about. That's why I looked into it. Now, is it going to be on Google Cloud anytime soon? I don't know. Yeah. But it's something I think all cloud providers, they have to think about at some point, because if it's going to be something comparable to containers, then yeah, you can't just ignore that, right? Yeah. Cool. All right. I will be outside the room, so if you have more questions, just catch me out there. Okay? Thank you.